Alright, so we're going to do a little bit of factoring review before we get into our full e-learning experience. This is the handout that's also posted. Now, if we notice, both of these are positive. So we know we're going to have an n here and an n here, and both of these are going to be positive. Alright, the factors of 14, that adds 9. Well, 14 and 9, there's only a few factors. There's 1 and 14, 2 and 7. So our factors are going to be 2 and 7. Remember, it could be written like this, or you could have n plus 7 and n plus 2. Alright, now go over here, very similar. We know we're going to have a v as our variable. Alright, this is where it gets a little interesting. We've got to think of the factors of 28, a negative 28, that combine to give us positive 3. Well, let's just go ahead and write some. Now, because this is negative and this b right here is positive, we know our bigger number has to be positive. So we could do 28, negative 1, 27. We could do 14, negative 2, gives us 12. Or we could do 7, negative 4. This is going to give us not the negative 28, Jeffries, our positive 3 that we needed. So we know we're going to have a positive 7, negative 4. All right, on the next part, well, same process. All right, if we look here, this is negative, but this right here is positive. This means that both of their signs are the same, and this tells us they're both negative. All right, factors of 6 add up to negative 7. Well, negative 3 and negative 2 gives us negative 5. Our factors are actually going to be negative 6 and negative 1. Okay. Remember, just reviewing a little bit. I got a little ahead because I was seeing all these negatives. We know one of them is going to be negative because our negative 30. This is negative right here, because you cannot multiply two negatives and get a negative. That just don't happen. All right. So a lot of people start saying 5 and 6, 15 and 2, and making sure our bigger number is negative. But it's actually going to be 10 and 3. All right. Dots, difference of two squares. Okay, and it's also funny that I did dots right there. Remember, this means that this is a perfect square and this is a perfect square. So we're going to have an x. One's going to be a plus, one's going to be a minus. The square root of 16 is 4. That's just kind of how easy that is. Now, if we look here, both of these are perfect squares. It's still a dots problem. It's not a GCF problem and then a dots. So, square root of 4 is 2. Remember, a plus and a minus. Square root of 81 is 9. There we go. Last, these are just GCF. Greatest common factor. All right. So this one doesn't have a variable right here. So we just take out the biggest number we can between 6 and 21. Okay, it's not going to be 6. 6 doesn't go into 21. It is, however, going to be 3. Okay, so I can take a 3 out. Put my GCF here. Well, 6 divided by 3 is 2. Just drag the y. And then 7 here. Now, over here gets a little bit more interesting because we have variables on both of them. All right, so the biggest number that can divide 12 and 18 is 6. All right, now remember with your variables, it's the lowest exponent. Well, the smaller of the two numbers is this right here. So w squared. So GCF goes right there. 12 divided by 6 is 2. You subtract. Minus 18 divided by 6 is 3. And those cancel. There you go.